In this video, we're going to take a look at the absolute value function. We're going to look just at the shape of the absolute value function, and we're also going to look at the general form of the absolute value function. So they're the two ideas that I sort of want to get through here. So an absolute value function, so f of x, here's our function, is equal to the absolute value of x. The absolute value of x. So you remember that if we sub a value in for x here, we'll get the absolute value that comes out. So if I put 5, if I sub 5 for x, 5 will come out. If I sub -7 in for x, then 7 will come out. So that's what our absolute value does. Let's take a look at the general shape of an absolute value function. If I can find it. There we go. Alright, here's an absolute value function. You can see the equation is f of x equals 1 times the absolute value of x. That's just a software thing. Really, the thing that you're looking at right here is f of x equals x. So, looking more closely, you can see that when x equals 1, y equals 1. When x equals 2, y equals 2. When x equals 3, y equals 3. When x equals 4, y equals 4. You get this straight line going off here. What happens is we get this little point here that we call a cusp, C-U-S-P. You get a cusp, and then when x is equal to -1, y is equal to 1. When x is equal to -2, y is equal to 2. -3, 3, -4, 4. That's how our absolute value function's working. So there's our that's the most basic absolute value function we can get. So there's our really basic absolute value function. It's not called a turning point, it's called a cusp, C-U-S-P. Now, obviously, that's a basic absolute value function, but we can change it, adjust it, using the values a, h, and k that you've already become familiar with. So this is our general form. We said we were going to talk about our general form. That's what we're doing here. F of x equals a times the absolute value of x minus h plus k. So let's run through each of the values, a, h, and k, and figure out what each of those does. You could probably take a guess. So I'm going to shift each of these just a little bit, if it'll work for me. Okay, so I've just shifted k to up here to 2. I've shifted h, let's shift h to 3, and let's shift a to 2. Okay, so hopefully you can see what was happening there. The h value and the k value are moving it left and right. That's the h value changing there, moves it left and right, and the k value moves it up and down. Now this is what you've come to expect from quadratics and from cubics and also from reciprocal functions. The h and the k value determine the cusp. So what we have here is h and k determine the cusp. Now remember, you've got to sort of change the sign on that h because it moves it in the opposite direction that you'd expect. So if it's -5 here, then this is going to be 5. Alright, so that's what h and k do. Oops, let's try that again. There we are. Now 2, you can see what 2 does is change the dilation of our absolute value function. And if I move it to negative, it turns our absolute value function upside down, a negative value there. And so that a value is determining the dilation of our absolute value function, and if a is greater than 0, then let's be a bit silly here and call this a happy one, and if a is less than 0, then it's going to be a sad absolute value function. Alright, that's absolute value functions. That's the general shape. You've learned some new terminology, the cusp, which h and k is, the a is the dilation, and the general form can be written as a absolute value of x minus h plus k.